Welcome, my dear students. Now, the last part of the periodic table, first ionization potential or ionization energy. It is one of the periodic property of the elements. Now, we have to know first what is first ionization potential or ionization energy. Actually, ionization energy is the minimum amount of energy which is required to remove the most loosely bound electron from the outermost cell. That is, in the outermost cell, outermost electron, most loosely bound outermost electron, to form a unipositively charged cation from an isolated gaseous atom in its ground state is called ionization energy of an element. So, ionization energy of an element, keep in your mind, is involved with isolated gaseous atoms. The most important information is that it is for isolated gaseous atoms, and it is the minimum amount of energy. Say from the left to right in a period, from left to right in a period, ionization energy or first ionization potential gradually increases. Say sodium, then magnesium. 11, sodium has the atomic number, magnesium 12, then aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. Argon is an inert gas, so it is not applicable for the inert gases. Sodium has the least ionization potential and chlorine has the maximum ionization potential. Now, what is the reason behind this? Because to remove one electron from the outermost cell of sodium, sodium has 3 cells. It has 11 atomic number. It has 3 cells, 2, 8, 1, and there is only one electron in the outermost cell. So it will be very much convenient to remove one electron from sodium from the outermost cell, only one electron. And sodium can form easily by removing one electron, a cation. So in the third period, the minimum amount of energy required for removing one electron from sodium is minimum. So the ionization potential or ionization energy for sodium is minimum. But for chlorine, its atomic number is 17. It has electronic configuration 287. In the outermost cell, there are 7 electrons. And chlorine has always the affinity to receive one electron in its outermost cell. It is very much inconvenient. It is very much cumbersome to remove one electron from chlorine from the outermost cell of chlorine, most loosely bound electron. So the maximum energy is required for removal of one electron from chlorine to form a cation. Therefore, the ionization potential of chlorine is maximum and that of sodium is minimum. We have already observed from left to right this potential or ionization energy gradually increases. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Regarding ionization potential, magnesium greater than sodium, aluminium greater than magnesium, silicon greater than aluminium, phosphorus greater, sulfur greater, chlorine greater. But in case of group, in a group from top to bottom, this happens oppositely. That is, ionization energy gradually decreases from top to bottom in a group. We take group 1, hydrogen, then lithium, then sodium, then potassium, etc. Now, hydrogen has only one shell. It has only one electron in the outermost shell. It has one cell. But in case of lithium, there are two cells. So the distance from the nucleus to the outermost cell is greater than that of hydrogen. So the force of attraction between the nucleus and the outermost electron is less than that of hydrogen. So it will be convenient to remove one electron from lithium than from hydrogen. So the minimum energy required for lithium is less than that of hydrogen. So ionization energy of lithium is less than that of hydrogen. In case of sodium, there are three shells. So the outermost shell has much greater distance than that of lithium. So ionization energy will be less. And in case of potassium, there are four shells. So the distance increases and the force of attraction decreases. So by applying less energy, this electron can be removed from the outermost shell. Therefore, the minimum quantity of energy required to remove one electron from potassium is less than that required for sodium. So it is clear from the discussion that the energy required for hydrogen is maximum and for potassium is minimum. So from the top to bottom, and prove this ionization energy or first ionization potential gradually decreases. But keep in your mind, there is an exception. In the second period, nitrogen has atomic number 7 and oxygen has atomic number 8. So, according to rules, the first ionization potential of oxygen should have been greater than nitrogen, but it has been observed that this is opposite and ionization potential of nitrogen is greater than oxygen. And the reason behind this will be discussed later on in a higher level. Now we are just closing the discussion of periodic table. Before going to that, I like to mention that these properties of the periodic properties of the element we have discussed about the periodic properties. There are some properties which are not periodic. For example, radioactivity is a non-periodic property. The periodic radioactivity is not a periodic property. It is not periodic property, keep in mind. And all others, electropositivity, electronegativity, the basic property, acidic property, reducing property, oxidizing property, etc. First ionization potential, etc. are the periodic property of the element. So keep this in your mind. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.